Hey everyone, good morning. Hope you're doing well. Hope you had a great weekend. Again, do weekends even exist? But anywho, I had a great weekend. Didn't do a lot. Did a lot of yard work. Went to the gym. Actually bought a treadmill too. But anyways, neither here nor there. An experiment is performed to test the toxicity of copper sulfate using brine shrimp as a test organism. So what they want you to do on this is they want you to graph the concentration versus the percentage of dead brine shrimp, and then they want you to find the LD50 for this copper sulfate. All right, so the first thing that you probably want to do is you probably want to determine the percentage of dead shrimp, because this is going to go on your y-axis and this is going to go on your x-axis. So what you're going to do is to get the percentage of dead shrimp, you're going to take the number of dead brine shrimp, divide it by the total number, which is 100, and then multiply it by 100. So if you've already guessed, 10 divided by 100 times 100, it's just going to be 10%. And if you want to do it on your calculator to prove it to yourself, then you can. So this is 10% again, this is 20%, this is 55%, this is 90%, and then this is 100%. Alright, so what I want you to do on letter A, it says plot these data on the graph provided below. Draw a smooth curve through the data points to illustrate the overall trend of the data. So what I'm going to do for the concentration, which is going to go on the x-axis, is I'm actually going to turn this into a log of concentration. And when I say log, I'm talking about the mathematical function where you say, okay, 10 to what power equals this. All right, so if this is x, this would be log x. And all I'm going to do is I'm going to take the log of this. And the reason that I'm doing this, I know some of you may be like, well, what the heck is he doing? If I was going to do this and get like the straight S-shaped curve here, I would be going from like 0.0001 all the way up to 10, which seems like a lot. So if I do log of the concentration, that's going to make it a lot easier. So here's what I'm going to do. I'm going to take my calculator and I'm going to do log of 0.0001, and that's going to give me -4, log of 0.001, and that's -3. And if you can guess the pattern, it's going to go -2, -1, 0, and then 1. Okay, so now I'm going to label this down here, and mine looks a little bit different because I expanded it out a little bit because I was running out of space. All right, so I'm going to say log of the concentration of CuSO4, and these braces just stand for concentration. All right, so what I'm going to do is I'm going to start my graph out at -4 down here, and then make it go to 1. And each one of these is going to be 0.5. So if this is -4 here, this would be -3, -2, -1, 0, and then 1. All right, so that's pretty easy. All right, so this is the log of the concentration of copper sulfate. All right, over here on the y-axis, I'm going to do the percentage of dead shrimp. This is a percentage. All right, so for this one, it goes from, it looks like, 10 all the way up to 100. So I'm just going to go up by 10s here. All right, so let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 10, 20, 30, 40, 50, 60, 70, 80, 90, right, 100. All right, so the first data point is you're going to do -4, and you're going to go over to 10%. So it's going to be -4, 10. All right, the next data point is -3, and also 10. All right, the next data point is going to be -2 and 20. So -2 and 20. All right, the next one is going to be -1 here and 55. So -1 and 55. So that's about right here. All right, 0 is going to be 90%. So that's going to be about right here. And then 1 is going to be 100%. So that goes right there. All right, and it wants you to connect the data points using a smooth curve. All right, so I'm going to connect these using a smooth curve, just like so. All right, so there we go. All right, so it gave you a title for the graph already, the LD test for copper sulfate. I graphed the log of the concentration of the data on the x-axis, and then I put the percentage of dead shrimp here on the y-axis. All right, so now it wants me to answer these questions. It says, explain the meaning of the term LD50. What is the LD50 of copper sulfate for brine shrimp? All right, so the meaning of the term LD50. All right, so let me move this out of the way here. We'll need in a second. All right, LD50 is the lethal dose that kills 50% of the population. Okay? And that's really all you have to say here. It just wants you to say that it's going to be the dose that kills 50% of the population. All right, it says, what is the LD50 of CuSO4, or copper sulfate, for brine shrimp? So what you're going to do is you're going to look at the graph. So here's the graph again. And you're going to go over to 50 on the y-axis. Just draw a little dash line over. And it intersects the graph right about there. All right. So, and again, since we don't really have, exact measurements along here, we only have these, you can say the LD50 is a little bit less than 1, or you can make up a number if you'd like. They will accept a range on the AP exam. All right, so LD50 is the lethal dose that kills 50% of the population. What is the LD50 for copper sulfate? The LD50 for CuSO4 for brine shrimp is slightly less than Alright, so since it's slightly less than -1 here, we have to go up here and look and see, okay, well, which one was associated with -1? It was 0.1. Alright, so it's slightly less than 0.1, and it's milligrams per liter. Alright, and I know I kind of confused you a little bit with that. So since I did the log base of the concentration down here, it's slightly less than this -1 here. So you have to go up here and say, okay, well, what was -1 before I changed it to the log base? So it was 0.1. So therefore it's slightly less than 0.1. All right, it says letter C, explain the meaning of the term threshold level of toxicity. What is the threshold level of toxicity for CuSO4 for brine shrimp? Label this point on the graph. All right, so the threshold level of toxicity is the point where you first begin to notice the effects of the chemical. And up here it says that the point, you could probably put concentration here as well. The concentration in which you first start to notice the effects of the chemical. So going back to the graph here, let's get another color. I've gone crazy with colors. All right, so here is the graph again, and we want to know what is the threshold level. So if you look at the graph here, it looks like the threshold level is going to be, it's where you first start to notice that it's, it's killing someone. On this one is kind of tricky because it didn't give you, the concentration at 0. So I'm going to say that you can, since this has already killed 10% of them, according to the graph, it's probably going to be about like right here. So you could also say, there are two different answers I'll accept for this. You could say that it's 0.0001, Or you could also say that it's slightly more than this -3, which would be slightly more than 0.001. All right. The threshold level is 0.0001 because the chemical is already having an effect. You may be wondering, okay, well, where in the world did you get this FRQ question? This is actually an old FRQ question from an old AP exam. I think it's back in the early 2000s, though. All right, letter D says, provide an argument for against extending these toxicity results to humans and one argument for doing so. All right, so if you didn't realize it, we talked about this the other day in our discussion about environmental toxicology. They are testing these on brine shrimp, and then they're extending the results out to humans. So provide one argument against extending these toxicity results. One argument against is that humans are not brine shrimp. And may metabolize the copper sulfate differently. All right, so that's one argument against. All right, one argument for. So one argument for is that the results for brine shrimp, let's just say results for brine shrimp will be divided by 1,000 to achieve a safe level for humans, and this is giving, I'm running out of space, giving us a baseline. Okay, so what I'm saying here is I'm saying that, remember we talked the other day about how we can extrapolate the data out to humans? Well, if we extrapolate this data out to humans, they're going to divide it by 1,000 anyway. So the toxicity level for brine shrimp is going to be divided by 1,000. This can really give us a baseline to see, how much is toxic. All right, thanks for watching this video. It's the first one. I'm going to do 3 separate videos for these.